Hello everyone, today we are going to discuss about dual voltage motors, and in that we are going to discuss about what is dual voltage motor and identifying whether the motor is connected in star or delta connection with the help of ohmmeter. And we are going to see low voltage star connection, high voltage star connection with respect to 9 terminals motor, and we are also going to see 12 leads connection type with a star star low voltage connection and star high voltage connection. Also, we are going to understand low voltage delta connection, high voltage delta connection, and 12 leads connection type for delta connection, high voltage. And we are going to see the performance comparison when it is connected appropriately with the voltage ratings with respect to the connections made wrongly or incorrectly for the motor. What happens to the performance? And finally, we will see the wiring diagram, how to connect these motors and how we can control these motors. So let us start now. What is a dual voltage motor? So these are like other three-phase induction motors, but these motors can operate with two different voltages without changing their performance, most of the performance parameters like torque, speed, power, all those things, power factor, all those things will be kept constant with respect to either high voltage configuration or low voltage configuration. So either configuration you will achieve the same power factor and same torque, but the voltage and current differences will be maintained. So in the high voltage configuration, the two coils of each phases are connected in series with each other. So it means in each phase you will have two coils, and if the two coils are connected in series, so it will be mentioned as high voltage configuration. And if the same two coils are connected in parallel, so it will be mentioned as a low voltage high current configuration. And it is very important to size motor starters and their overload relays based on expected value of current that is to be drawn by the motor at voltage it is used. So in case if you have high voltage motor configuration, that time the current ratings may be lesser. In other hand, if you have high current configuration, that is a low voltage configuration, the current ratings will be higher. So based on which configuration you are going to use this motor, so the overload relays and the motor starters will be chosen. So how this power balance taken place in the motor? It is very simple to understand. So if you take 20 units of 60 units of power, so in that if you consider 20 units of power voltage and 3 units of current to contribute to 60 units of power, and if you increase or decrease any one of this parameter, so you can balance the power. So in case if the voltage is increased, the current will be decreased. In the vice versa case, if the voltage is decreased, then the current will be increased. So by anyhow the power will be maintained constant. So that is how the power balance is taking place in the dual voltage motor. So the wiring configuration inside the motor will be looks like this. So each phase coil will be split into two different coils. So these coils can be connected either in series connection or in parallel connection according to the requirement, whether you are going to use it in a high voltage configuration or in a low voltage configuration. Also, the motor manufacturer itself will say the motor either it is a star connected motor or delta connected motor. So based on that, they will make the configuration inside so that they connect these two coils in such a way that either it forms a star connection or delta connection. So in case if you have a motor and you don't know the nameplate details and you don't know how to identify whether it is a star connection motor or delta connection motor, I am going to show you how you can check this motor terminals and to find out whether it is a star connected motor or a delta connected motors. So these motors usually will have either 9 terminals or 9 wires coming out of the motor, or it may have 12 wires coming out of the motor. Two different configurations are available. So this, if it is a 9 wire motor, so the wires or the leads will be number from 1 to 9 in both star connection and the delta connection. So based on these voltage wiring connections, either you can have high voltage or low voltage star, or high voltage or low voltage delta connection. So four different configuration is possible for this dual voltage motors. So let us see this. There are terminals numbers denoted here. So let us assume I don't know anything about the numbers and then the configuration and the nameplate detail of this motor. How to identify whether it is a star connected motor or a delta connected motor? By using a simple technique with the help of resistance measuring a device by doing the continuity test. So we know what we mean by continuity test. So simply by measuring the resistance between the coils, you can come to know whether there is a continuity or not. So we should have a table and verify whether the table is satisfied with this, so that whether it is satisfying the delta configuration or it is satisfying the star configuration. So if you connect the multimeter across this coil like this, so the resistance will have a small value of resistance, either it may be 4 ohms or 5 ohms based on the motor. Different type of motors, it may be different values as well. And if you are connecting the same first terminal with the seventh terminal with the same ohm meter, what is going to happen? It is going to show the infinite resistance. So I'm going to measure the resistance here across 1 and 7. So the resistance will be infinite. So what we have to do first, we have to take any one terminal and connect with the other terminal one by one and note down the resistance. So where you are getting the resistance, just mark it that particular terminal and just keep aside. Say if I measure the resistance across the different terminals of this, so I will get only the resistance between 1 and 4 resistance value. Other values will be infinite. So 1 and 7, 1 and 9, and 1 and 6, 1 and 3, 1 and 8, 1 and 5, and 1 and 2, different combinations, but all the values will be infinite values of resistance except 1 and 4. So if you have only resistance between these two terminals, so that means you can almost ensure that it is the star connection. But don't go to the conclusion. What we have to do, we have to check other terminals as well. So let us take the next terminal. So let me assume that I have taken this terminal and I measure the resistance between the next terminal. So for example, I have connected between these two. So the resistance will be a small value will be present here. And since I have already got value between 1 and 2, I am not going to use these two terminals. Remaining all terminals I am going to check with respect to 3. So 3 and 6, 3 and 7, 3 and 8, 3 and 5, 3 and 2. All this is going to give me infinite resistance except 3 and 6. So I got 1 and 4 some value. So this is one coil, and 3 and 6 I got some value, and this is one resistance or one coil. And again similarly I am going to connect this coil with respect to other terminals. So 2 and 5 is going to give me some resistance. So now I need not to measure between 1 and 4 with 1 and 4. Also 3 and 6 I can avoid. So I can measure with respect to 2, with respect to 5, which I got some value. Here I get some values. And if I measure between 2 and 8, it will be an infinite value. 2 and 7, it is going to be infinite. 2 and 9, and 2 and 6 also it is going to be infinite. So once I get these values, so 3 coils I get value. So almost I can say that it is a star connection. Now final value, so these 3 terminals, so this is having a pair of terminals where resistance is there, and here also we found, here also we found. So remaining 3 terminals are left. So if you connect the resistance meter between any of these two terminals, so you may get the values. So here also you will get value, here also you get value, and here also you get value, because there is a continuity between these coils. So if you get this combination, if the values is something like this, you can conclude that this is a star connection. Okay, so this is a star connection. So By this, without having any nameplate detail, you can identify it is a star connected motor, and this can be connected either in a parallel connection or in a series connection to obtain high voltage or a low voltage configuration. And we cannot connect this motor for delta connection since it is already connected in a star connected. Inside you can see it is inside this one pair, one set of coil is connected already in a star connection, so it is not possible to connect it in a delta configuration. So if you connect this motor by any chance in delta configuration, then it may give up, the motor may damage or it will not run appropriately. So for delta configuration, in similar way, we are going to follow the same methodology. So we are going to have the Ohmmeter, and we will take the Ohmmeter and measure the resistance. Now only the difference is, with respect to any one terminal, you will get 2 points values. So 1 and 4 you get value, and 1 and 9 also you get value. In previous case, what we have obtained, only with respect to one terminal I get the resistance, other 2 terminals I did not get. But now you can see here, in one terminal I get 2 values of resistance. And similarly, if you measure, say for example from here I measure, I get value, and from here I measure, I get value, and here to here again I get some value. And if you see, say this is R1 and this is R2 and this is R3. If you take this as a value, you can easily understand that R3 will be approximately equal to R1 plus R2. So if you get this, almost you can assume that it is a delta connected motor. Okay, so in the same pattern you will get here for this pair of coil and this pair of coil, so that means it is a delta connected motor. Yeah. And now let us see low voltage star connection. In low voltage star connection, 2 coils of star connected phase will be connected in parallel. So that means the current whichever is coming from here will be get divided. The current whatever is coming from here will be get divided into these 2 coils. So the current can be higher, and the voltage will be maintained the same between these 2 coils. So the voltage will be lesser. So this is a low voltage high current configuration. It is connected in star connection. So when we get this kind of motor, the nameplate or the connection terminal, you can connect U2, V2, W2 shorted, or you can see 4, 5, 6. These 3 terminals will be shorted. 1 and 7 is connected, and it is connected to L1. And you can see 2 and 2 is connected to 8. 2 and 8 connected to L2. 3 and 9 connected to L3. So remaining terminals 6, 5 and 4 interconnected. So when we connect like this, so this will leads to low voltage star connection. And when you want to connect it for high voltage, we will see in the next slide. Now here you can see in the motor nameplate, you will have the terminal box like this. So L1 is coming here, so it is connected to T1 and T7. L1 is connected to T1 and T7, so L1 connected to T1 and T7. L2 connected to T2 and T8. L2 connected to T2 and T8. And L3 connected to T3 and T9. L3 connected to T3 and T9. So this is how the connection will be made. And T4, T5, T6 will be shorted. Okay, so that will be shorted. T6, T5, T4 will be shorted. When we make the connection like this, so that means it will be giving us a low voltage star connected motor. And if you want to make that same motor as a high voltage star connection. So we are going to make the wiring in different way. So where we are going to connect L1 with terminal 1. So here we are going to connect L1. Here we are going to connect L1, and here we are going to connect the L2, and here we are going to connect L3, and we are going to short the terminal 6 and 9, 8 and 5, 4 and 7. So that is what is given here. So U2 and U5. So different denominations are given, or different number methods are given here. So here numbering and here letterings are given. So U2 and U5 is shorted, V2 and V5, W2 and W5 is shorted. And the connections are given with L1 U1, L2 V1, L3 W1. So if this is the case, then it will behave as a high voltage star connected motor. So the same thing is given here in the wiring terminal. And here the next one is 12 lead connection type star connection or low voltage configuration. Here, what is the difference between the previous one 9 lead terminal and the 12 lead connection? So here none of them are connected by the manufacturer. All the wires are kept outside, and you are going to connect it in the way what you need. Either you want it in a star connection or in a delta connection. So you can decide. If you want it in a star connection, so you will short U2 U6, V2 V6, W2 W6 first, and these will be connected, shorted each other, and U1 U5 is shorted and it is connected to L1. So this is for the low voltage configuration I am speaking about, and V1 V5 is connected and connected to L2, W1 W5 is shorted and connected to L3. So this is the wiring configuration for 12 lead connection type star connection low voltage. For high voltage, U6, V6, W6. So these three will be shorted. Actually, in 9 volt in a 9 terminal configuration, these three will be connected by the manufacturer itself. U6, W6 and V6 will be interconnected by the manufacturer itself, so that it can act only as a star connected motor. But now you have a freedom to connect either it is in a star connected or a delta connected in a 12 lead connection type, and also you have freedom whether you want to connect it in a high voltage configuration or a low voltage configuration. So in here it is a high voltage configuration. So L1 will be connected to U1, L2 will be connected to V1, L3 will be connected to W1, and U2 U5 shorted, V2 V5 shorted, W2 and W5 shorted, and these three U6 V6 W6 will be shorted as well. If you connect this way, so it will act as a star connection high voltage configuration. And for a delta configuration for low voltage, so the coils will be connected in parallel method. So where the input supply will be connected to L1 to the first terminal here. So where it will be given to 3 terminal or 3 points are connected to this L1. So it is terminal 1, terminal 6 and terminal 7. So these 3 are connected with L1, and L2 supply L2 is connected to terminal 2 and terminal 8 and terminal 4. This and this one. So L2 and L3. This is L3 connected to terminal 3, terminal 5 and terminal 9, and there is no tie together. So if you connect this way, when you have 9 terminals given, if you connect this way, so this will act as a low voltage delta configuration. And high voltage delta configuration, it's very simple. You connected L1 here, L2 at the second terminal, L3 at the third terminal, short 4 and 7, short 5 and 8, short 6 and 9, so that it acts as a high voltage delta configuration. So 12 lead connection type for delta connection. Also you can see here L1 connected to an U1 and W6. L1 connected to U1 and W6. and L2 connected to U6 and V1. This is V1 and U6. L3 connected to W1 and V6. W1 and V6. And the remaining things, W2, W5 will be shorted, U2, U5 will be shorted, V2, V5 will be shorted. If you connect in this configuration or in this method, it will act as a high voltage delta configuration. So these are the different possible configurations for this motors, either it is a 9 terminal dual voltage motor or 12 terminal dual voltage motor. So now let us see how the nameplate will be looks like for this dual voltage motor and how the performance will be. And you can observe here it is a 185 watts, 185 kilowatts 4 pole 220 bar 380 volt motor. In 220 volt it will be connected in a delta connection, and 380 volt it will be connected in a star connection. So that means in low voltage it should be connected in delta, and for high voltage it should be connected in star connection. So in that case, if you connect appropriately, so the power will be 185 in both full load condition, and voltage 220, 380, and the current you can see here 539, 312, and the starting current is almost 500% of the full load current, so it is nothing but 2000 sorry 697, and here the full load current, if it is almost 500%, you can see 1562. It is almost okay, it is not exact value, and the efficiency remains same for both configuration, star or delta configuration, 94.1, and the speed remains same, 1487 and 1487. Torque produced also is the same at full load condition, 1188, 1188. So the configuration, the current and voltage changes with respect to whether it is a star connection or delta connection, but the remaining parameters, power, efficiency, power factor, speed, torque, all those things are going to be same for both configuration. In case if you have connected wrongly, what is going to happen? So this motor at low voltage it must be connected to delta, and high voltage it must be connected to star. This is the manufacturer specification. But if you have connected wrongly, what is going to happen? Let us see here. So it is for low voltage, delta connection should be there, so it is connected, so it is going to give appropriate performance, no problem. But here instead of star connection, we have connected in delta. So what is going to happen? So certain things you can observe here. So the torque, what is going to happen? So the power, what is going to be, and remaining everything you can see here. So the efficiency dropped from 94 to 78.7, and the power factor 0.9 to 0.19. So you can see the difference. The power factor reduced to almost 0.9 to 0.2, and then speed it's almost okay, and torque is also almost okay, but the difference is with the efficiency and the power factor. And also you can see the current. This is a very important thing. So when we connect it in star connection, so you get almost 312 amperes of current, 312 amperes of current. But now what happens? It is a 1480. So that means it is almost 500 times or 500% of the normal expected current. So in a star connection you get almost 300 plus, but here in delta connection you get 1500. So it is almost 5 times the expected current. So it is going to damage the coil and the insulation, and if your overload relay and the protective mechanisms are working good, so it may trip, so it will not allow the motor to run. In case if the OLR and then the protective devices are not appropriately functioning, then it may damage the motor. In case if you connected both in star connection, so of course for high voltage you must connect it in star connection, so the performance is not going to be affected. So this is going to be as usual. But when it is coming to star connection with a low voltage configuration, what is going to happen? So the current taken also reduced. So You can see here this is the voltage, and the current taken is reduced, and the power factor reduced a bit, and the efficiency also reduced a bit. Speed okay, and the torque is reduced from 1188 to 815. So this means, so the load handling capacity of this particular motor is going to be reduced, and if you give extra load, then the motor speed will be reduced drastically. At one particular stage, the motor will stall or it will not run. So this is the problem with connecting a star connected motor to with a low voltage configuration for this particular motor. I just giving a comparison for this particular motor. So this is how the performance will be affected. And now let us see how the motor connection is taking place. Actually here this dual voltage motor used for path winding starting. So it is only used for path winding starting. So just to understand how the path winding method is connected here, but actually in actual practice we need not to have this timer and everything. So in case if you want a star connection, here it is permanently connected in a uh, low voltage configuration. Low voltage configuration, this though it is a dual voltage motor, it is connected in a low voltage delta star configuration, low voltage star configuration, and it is started with, when we are starting this. So here you will have only this coil. So this coil, so the coil resistance will be higher, and when you are time delay, here the time delay, if it is lapsed, then the second contactor will be turned on. So these two will be coil 1 and coil 2 will be connected in parallel. So the resistance will be dropped, so the current can be increased, and so by that time, the torque requirement also can be achieved. So that is how the dual voltage motor connected for path winding starting. So actually this particular topic I have discussed in our previous video. If you have any doubt, please check it out with that video. So this is a dual voltage motor used for path winding starting. Thank you. I hope you understood the concepts. If you have any doubts, please let me know in the chat box.